Hello everyone. Today we are going to solve some of the problems on counting in set theory. Okay. Now coming to the problem that we have got. We have got a class which is having 60 students. Okay. 30 students like C++, 25 students like Java and 10 students like both. So whenever you are solving a question, write whatever is given. You have got two choices. Either you can write given total number of students is equal to 60. Students who like C++ is equal to 30, and students who like Java are 25, and students who like both C++ and Java are 10. Therefore, let me consider two variables like let set of students who like C++ be A, and set of students who like Java be B. Okay. Therefore, number of elements in set A is equal to number of elements in set A. It means C++. It is 30. Or you can write like this also. You can write number of elements in A is equal to 30. This is also correct. And number of elements in set B. Set B means student those who like Java are 25. Okay. And number of students those who like the students are liking both, you need to use the intersection symbol, and it is the number of students who are going to like both the languages. Okay. Now coming to the very important part of the question. We can calculate n number of A union B is equal to using a very important formula, number of elements in set A plus number of elements in set B minus number of elements in set A intersection B, and this is equal to 30 plus 25 minus 10, and this will be equal to 55 minus 10, and this is equal to 45. Now let's draw the Venn diagram for our question. Okay, this is our universal set. This is our class which is going to contain 60 students, and we have got two sets in that. If you see, I have got A intersection B. It means I need to draw A intersection B. This is A and this is B. Now if you try telling me number of students in the given set, see, A intersection B is having 10 elements, and this A is going to contain total how many elements? 30 elements. Already I have written 10, so remaining are 20. Similarly, set B is having 25 elements. This is 25 elements, and the remaining are around 15 elements, because this is total 25. Already I have taken 10, so it is 25. And if you calculate all of this 20, 10, and 15, you get it as 45, and that is already here. And the remaining out of 60 are here, who do not like anything, they are here. Okay, now let's go to the first question. First question is, how many students like at least one programming language? Whenever you are solving this question, you need to remember at least one means number of students who like one language or two language. At least one means greater than or equal to, at least one means greater than or equal to one. So it can be one language or two language. Now let's calculate from the Venn diagram. If you see these students, if you see these students, okay, they are students who like C++, these are students who like Java, right? If you see this area, these students are going to like only C++, and these students are going to like only Java. And if you see these, they are going to like both. So if the question is like this, then you need to solve for number of students who like only one language plus number of students who like only two language. You can have number of students who like only three languages also correct, four also correct, but in this case we have got only two languages, so we'll not be using these two. Okay. Now therefore number of students who like only one language is 20 plus 15, and plus number of students who like, this is 20 plus 15, number of students who like two languages are 10, therefore it will be 45. So the answer for the first question is 45. Therefore number of students who like both languages is 45. Okay. Coming to the second question, how many likes at most one programming language? Now second one, how many likes at most one programming language? See, if you look at this, at most means less than or equal to 1. At most 1 means less than or equal to 1. Number of students who like 1 or number of students who like 0. Therefore, this implies number of students who like one language plus number of students who like 0 language. Okay, and therefore if you see from the Venn diagram, if you see from Venn diagram, there are 15 students who does not like any language, and there are 15 plus 20 students who like one language. So you can write 20 plus 15 plus 15, and this will be equal to 50 students. Therefore there are 50 students who like at most one programming language. Now coming to the last question. How many students like no programming languages? As you can see that we have found out here, this particular region is going to be the number of students who does not like anything, and therefore we have got 15. Here directly you can say the question number 3, there are 15 students who does not like any programming language. There are 15 students who does not like, and this is the answer for your question. Thank you.